Hello everyone, my name is Joan Chuarsa from SMA1 IPAB. Today I'll be discussing about coefficient of kinetic friction. Coefficient of kinetic friction. First, we need to know what is friction. Friction is a force that opposes motion. Friction is always slows down a moving object. There are two classifications of friction. First is a friction between two solid bodies, and second is fluid friction. A friction between two solid bodies is classified into three. First is static friction. Static friction presents in solid bodies at rest. This is a diagram of static friction. As we can see, there is no motion in it, but there is still a friction occurs in it. To learn more about static friction, here is the example of static friction. Static friction comes when objects are moving. When you are walking, static friction pushes in the direction of you are trying to move. The foot pushes on the ground, and without friction, the foot would slide backwards. Static friction pushes the direction that prevents the foot from sliding, which results in forward motion. The second is sliding friction. Sliding friction presents when one solid slides over another. This is the diagram of sliding friction. As we can see in this diagram, the friction is acting opposes the motion of the box. Here is the examples of sliding friction. When we are pushing a box, sometimes it's hard for us to move the box because there is a sliding friction that occurs in this. Occurs between the box and the surface of the floor. And the last one is the rolling friction. Rolling friction presents when one solid rolls over another. Here is the diagram of the rolling friction. As we can see, the motion in this diagram is moving upward. That means that the solid rolls forward, and the friction is still opposes the motion. And here's the example of rolling friction. When we push on wheel, the wheel rolls forward, and eventually the wheel stops rolling. This is because there is a friction between the wheel and the surface of the ground. Next is the fluid friction. Fluid friction is the friction present in liquid and gases. Fluid in here means that something that can move easily, like liquid and gases. So fluid friction is a liquid and gases. Here's the diagram of fluid friction. The object is moving to the left, to the right, but the fluid friction is moving to the left. This means that fluid friction is a friction that moves opposite side to the direction of the motion. For example, is riding a bike, surfing, swimming, skydiving, and etc. This is the formula of kinetic friction or sliding friction. F equals to mu times N. F in here is the friction force. Mu is the coefficient of kinetic friction, and N is the normal force. Here's the diagram of the kinetic friction or sliding friction. F goes to the left, that means it is the friction force. To the right is the direction of the motion. To the up is the normal force. And to the down is the weight, or the mass times gravity force, or G. Here is the first example. A small box of mass 15 kg rests on a rough horizontal plane. The coefficient of friction between the box and the plane is 0.2. What is the frictional force when the block is made to slide over the floor? First, we need to write the given. The given is M, or mass, equals to 15 kg. The mu is 0.2, and we need to find the frictional force or the F. Then we need to interpret the diagram. The frictional force is going to the left. The normal force is always 90 degrees from the surface of the thing. And the mass is always 90 degrees from the thing, or always pushes down. Next, we need to write the formula first. F equals to mu times N. Since we don't know N, so we need to find the N with the formula of sigma F equals to m times A, or mass times acceleration. N minus 15g, this is the N and the 15g, equals to 15 times 0. Why it is 0, the acceleration? Because this box is not moving at all, so the acceleration is 0. Then we write N minus 15g equals to 0. N equals to 15g. So 15 times 9.8. So N equals to 148. Since this is two significant number and this is three significant number, so we need to round it up to 150 Newton. And this is the final answer of the N. Then we substitute the 150 to the formula just now. F equals to mu 0.2 and N is 150. So now we get F equals to 30 Newton. And this is the final answer of the frictional force. Next is the second example. A block of wood with mass 1 kg is clamped to a vertical board with a force of 10 newtons. What is the minimal vertical force needed to move the block upward? And the mu is 0.50. First, we need to write the given. Given m equals to 1 kg, mu equals to 0.50, n equals to 10 newton, and we need to find the minimum vertical force needed to move the block upward. So now we need to interpret the diagram. N is the force to clamp the block of wood to the board, and N is the normal force. Why I write this? The normal force is 10 newton because there's only two forces in here. First, 10 newton is going there, and the N is going here. So if we find it, sigma Fy equals to 0 because there is no acceleration. So N equals to 10 newton. Next, we interpret the force that we need. And the last is the frictional force and the weight, or M times G. First is sigma F equals to M times A. This one is sigma Fy because it is over the y-axis. F is moving upward, so it is positive, minus F. This one is going down, so it's negative, and the M times G is also negative. M times A equals to 0 because there is no acceleration in it, or the block of wood is not moving. So we transfer the F and M plus G to the right. So the force needed equals the frictional force plus M times G. We don't know the frictional force, so we need to substitute the formula of F equals to mu times N to this formula. So F equals to mu times N plus M times G. So F equals to 0.5 times 10 plus 1 times 9.8. So F is equal to 11.3. Since this is 3 significant number, so we need to make it to 2 significant number. Because in here, the smallest significant number is 2. So we round it off and become F equals to 11 Newton. And this is the final answer. Thank you for watching this video.